Okay, so we've been doing stoichiometry, and the first thing to recognize is when we talk stoic is reminder about remembering the difference between the coefficients and the subscripts. And remember that when we look at this relationship, basically anytime you see a coefficient, you're looking at a molar relationship. So it's a ratio of moles. And that's a terrible box, but that's the idea. Now, remember when we do stoichiometry, we always start with substance A. We convert it to moles. We use the molar ratio to get from moles of substance A to moles of substance B, and then we get out of moles to get grams or whatever it is we're trying to solve for. Now, the reason we care about this is with limiting reactants. Limiting reactants are basically, whenever we do chemistry normally, this is usually what we're dealing with, is we're dealing with a limiting reactant. We're trying to figure out how much of something is going to give us something else. So when you look at this, you can see we have a pound of butter. Okay, you have maybe a cup or half a cup of sugar. We have a full flour bin, we have a full gallon of milk, and we have 12 eggs. So really, which one is going to limit the number of cookies cooked? Well, the sugar. Okay, so the sugar is really what limits the cookies. Okay, it limits how much I can produce. That's what a limiting reactant is. So when I look at this, that means it limits. So a limiting reactant, basic definition, when we talk a limiting reactant, okay, a limiting reactant, what it does is it limits the amount of product. I mean, it's that simple, guys. So that's all there is to it. So when you look at this, for example, I have hydrogen. Okay, you can see the hydrogen. I have the oxygen. Okay, so the hydrogen is the white. Okay, this is my hydrogen. Here's my oxygen. Okay, so you can see I have all of this before, and then when I get done, I have H2Os and I have some O2s left over. So what was consumed? Well, the hydrogen was consumed. Therefore, the hydrogen is the limiting reactant. Okay, and again, it determined the maximum amount of product. If all of my oxygens had reacted, I would have had how many oxygens? How many more waters? Well, 1, 2, 3, 4. I would have had 4 more. Okay, so we can see that since there's stuff left over, the oxygen is excess. I have too much of it. The hydrogen has been completely used. There's no hydrogen over here, so it was the limiting. It was the limit in terms of the product. And so that's what we see. So we see excess reagents, we see limiting reagents, and we go through and do that. So I'm going to show you the video. The main thing I want you to do is to recognize within the video how can we go from an equation. So you want to determine what the reaction is. So we're kind of doing a bunch of things here. I want you to figure out the equation in your notes. Then I want you to do it just in terms of moles. So if I have 1 mole of each substance, so 1 mole of reactant 1, okay, and 1 mole of reactant 2, take it to one product. Now, the cool thing here is when we look at H2 and O2, H2 reacting with O2, there's a single product. Okay, that's not always the case, especially when we do the baby bottle labs tomorrow. The baby bottle labs are actually going to have 3 separate products. Okay, so when we talk a limiting reactant lab and you have to determine, you're going to take the molar amount of each reactant to grams of hydrogen gas. Okay, so you're going to go through that. Hydrogen, in terms of baby bottle, it might be one of the products. It doesn't matter which product you go to, so long as you take both reactants to the same product. And so I've specified here, I want you guys to go to hydrogen. And I'm going to change it. I don't want you to do grams. Just go to moles. Just go moles to moles. Don't even worry about going to grams. Just go moles to moles. So let me get the video. Okay, here we go. Oops, hold on. Slight problem. Okay, a little sound difficulty. Here we go.
The extent of a reaction in any chemical process may be limited by the amount of one of the reactants. That reactant is called the limiting reagent. For example, zinc metal reacts with hydrochloric acid to form zinc chloride and hydrogen gas. When 2.5 times 10 to the negative third moles of zinc is reacted with exactly twice as many moles of hydrochloric acid, the metal will react with the acid to yield both zinc chloride and 61 milliliters of hydrogen gas. This apparatus will enable us to demonstrate the concept of limiting reagents.
Okay, guys, don't get too carried away with what they said about the volumes that are produced and in terms of this little apparatus. The main thing to notice with this apparatus is the change in the volume based on the amount of reaction here. And so what it does is it creates changes in pressure. The main thing is to look at how the volume changes in response to the amount of zinc chloride used.
The amount of gas evolved is measured in a gas burette. The round flask is moved up and down as needed to match the levels inside and outside, thus maintaining constant atmospheric pressure. When the zinc metal is added to the acid solution, it reacts, liberating hydrogen gas. This hydrogen gas is then collected in the gas burette, which is balanced by the leveling bulb. When all of the zinc has reacted, the amount of hydrogen gas generated is 61 milliliters. When we use only half as much zinc, this time only 82 milligrams with the same amount of hydrochloric acid as before, the metal will react with the acid to yield 30.5 milliliters of hydrogen gas. Because we have used half of the stoichiometric amount, all of the...
Okay, guys, right there, that's the key. Remember, whenever we talk balancing reactions, we're always talking in terms of stoichiometric amounts.
Zinc is consumed in the reaction. And as predicted, the hydrogen gas in the gas burette is 30.5 milliliters, or half the previous amount. In this case, zinc is the limiting reagent. This last experiment begins with 200 milligrams of zinc, an excess of metal. At the completion of the reaction, unreacted zinc remains in the flask. The same amount of hydrogen gas was generated as in the first experiment, 61 milliliters. The reaction came to a halt when all the hydrochloric acid was consumed. In this case, HCl was the limiting reagent.
Okay, and that's basically the point, guys, is just to recognize limiting reagents versus excess reagents. Now, again, when we do this, the main thing I want you to recognize, whoops, let's undo that. Okay, the main thing, again, when you're doing this calculation, what I want you to practice is they gave you the equation. I literally want you to start with something, let's keep it simple. Start with 0.5 moles of zinc. Start with 0.5 moles of hydrochloric acid. And then do the conversion for both to moles of hydrogen gas, just to kind of look at that. And then change with these amounts, keeping the other constant. And look at what happens. So if I have 0.5 moles of zinc, okay, how much am I going to get? If I have 0.5 moles of HCl, how much am I going to get? Which one's going to produce the least amount? Okay, and that's all a limiting reactant is. All right, so now theoretical yield. Now we did this a little bit when we looked at percent yield from the sodium chloride lab. Okay, the main point that I made in class that I want you to remember is that when we talk theoretical yield is always calculated. It's always from a calculation. Now, in the case of limiting reagent stoichiometry, it's always the calculated from the Stoich problem. But the point is theoretical is always by way of a calculation. It's what you should get if everything went perfectly. So, percent yield, like we did in class, okay, percent yield is going to be actual over theoretical times 100. That is percent yield. Now, the main point that I made with the practice problem that we did in class is if I know any two of these, I can determine the other. Okay, remember theoretical, whoops, that's a terrible arrow, isn't it? There we go. Theoretical is always from a calculation, typically a Stoich problem. Percent yield is the comparison of the two. Actual is always from data or the lab. Okay, so that's the difference. And that's the main thing you have to remember about these. So actual yield is, again, what you actually produce and measure from the lab. Theoretical is the other. Now, what's interesting is the different things we can do. We can do all kinds of things stoichiometrically with this. So again, just pay attention to what's going on, make sure you understand the basic Stoich, and you're good.